I've been inspired to learn more about mechanical design by retired mechanical engineer and YouTuber Thang010146. His YouTube channel has over 3,000 mechanical animations that he created himself, and he's constantly creating new ones almost daily. I've been a fan for a while now, and I would like to challenge myself to recreate some of his designs and 3D print them to see how well they function out of a printer. He's a genius. You gotta check him out if you're interested. This is an Oldham coupling, and it consists of 3 slotted elements that allow for parallel misalignment between shafts. Practical applications of the Oldham typically include stepper motor-driven positioning and other intermittent motion systems. You can get minimal backlash if you use polymer sliding block with tight tolerances, but that block will wear out over time, so you have to replace it to keep it fresh. Here is the final result. I didn't want to use anything that wasn't 3D printed, but however, I did put 2 pins in there to help attach the coupler to the shaft. So here's a little attachment that I'm going to put into a drill chuck so we can spin this at a higher RPM. This drill is rated for 800 RPM unloaded, so we are there or a little bit less in terms of RPM. This is a flywheel made out of pennies, and is going to help simulate a little bit of a load and give us a better representation of how these couplers actually perform. And there's no binding, it's running pretty smooth, not too bad. Here's a high-speed shot of the coupler in action. You can see that there's a pretty exaggerated gap. The parallel misalignment between these shafts is pretty substantial, and that means there's a lot of friction, and that block has to move quite a distance. And it does it. I mean, it seems to work fine, and this is a lower RPM, very low load test, but for what it is, it seems to work well. So here it is on a block of wood, just to get it out of my hand, and you can see it kind of shake around and move around a little bit. So I don't think that anything in the system is particularly well balanced, so those vibrations could be coming from anywhere. But if I was to take a guess and look at this, I would say that a lot of vibrations come from that little coupler disc, having to move up and down, aligning with the upper shaft and then realigning with the lower shaft. I would think that's probably where you're getting a lot of vibrations. Here's a hand test, just spinning it with the energy the freewheel has, and it goes pretty smoothly. It really is not binding, it's pretty smooth. Is this a practical print or not? Yeah, I'd say that it is.